Welcome to the Korf tutorials. Today we will show how to perform flash calculations. Let's start again with a simple system containing a control valve and two pipe segments. There are 4 steps required before performing flash calculations. 1. Create the circuit and run the hydraulics to initialize all flows and pressures. 2. Select the thermodynamic method. 3. Select the components. And 4. Define feed compositions and conditions. Before running the simulation, let's configure the results. Select Flow, Equipment Pressure Drops, and Valve CV. Click OK to return to the previous screen. Run the hydraulics only to initialize all flows and pressures. Ensure that the simulation converges and all the flows from feeds and flows to products are positive. To select the thermodynamic method, go to the Tools menu and click on Options. As we will simulate a water system, move to the Process tab and define ONT1 for the K-value method and WS97 for enthalpy. Keep all the other values the same and click OK. Note that you must define the thermodynamic method before selecting any components in pipe segments. To select the components, go to the Process menu and click on Components. Search for water. Then click Add to include it in the selected components space. Click OK. To define the feed compositions, right-click on the first pipe and select Edit Fluid. Move to the Composition tab and specify a value of 1.0 for water and hit Enter. Then, go to the Conditions tab and increase the temperature to 150 degrees Celsius. Check that the pressure is reasonable. Finally, select Constant Temperature and Pressure, or DP, for the flash type. Korf offers a preliminary check of the flash calculation by clicking on the button below the flash type. This allows the user to identify potential problems in the configuration. Click on Flash and verify that there are no error messages. Then, click OK to close the dialog, and OK to store the fluid dialog changes. Now click the H and H button to run both the heat and material balance and hydraulics. Accept the warning about compositions and properties, and after a few iterations, Korf will find a solution. Note that this method will propagate fluid properties to other pipes as required, so there is no need to update fluid properties for every pipe. Click on Results and go to the Conditions tab. Select Liquid Fraction, Flash Type, Total Density and Viscosity. Click OK. We can see that the second pipe used input from the first one, and the composition and fractions after the flash were calculated by Korf. Congratulations! Now you know how to perform flash calculations.